So the other thing we need to do is to be able to write the formula. So we need to be able to look at a name and be able to write the formula for that compound. And this can be a little tricky. So the first thing we would need to do is decide whether we're talking about an ionic compound or a covalent compound. So if we're looking at a name, what would be the first question we would want to ask ourselves in order to determine whether it is ionic or covalent? Just like before, whether we're looking at the symbol or the name, we would look at the first element and decide whether it is a metal, because the difference between ionics and covalents is that an ionic is always going to start with a metal. So if the answer is yes, then we are dealing with something that is ionic. Okay? Now, looking at the name, now that we know that it is ionic, we need to start with the metal. So what would be the first question we need to ask ourselves about the name in order to figure out which way to go? Is there a Roman numeral? Okay, remember monovalent compounds would not have a Roman numeral because their charge is always the same, whereas a multivalent metal would have a Roman numeral because their charge can vary. So if there is not a Roman numeral, so the answer here is no. You are going to look up the charge of the metal on your periodic table. Okay? Group 1 is +1, group 2 is +2, aluminum is 3, cadmium and zinc are +2, and silver is +1. All right, what if there is a Roman numeral? Well, that Roman numeral indicates to us that there can potentially be more than one charge, and so they're telling us what the charge is. Remember, the Roman numeral is the charge of the metal. So that is the charge of the metal. Okay? So that takes care of the metal piece of this. Now we have the charge of our metal, we know the symbol of our metal, and so the next thing we need to do is to look at the second part. And in looking at the second part, we need to try to decide if this is going to be binary or non-binary. So what would be the next most important question we would want to ask ourselves in order to determine if this is binary or non-binary? Okay, our next important question is about the ending. Does it end, that second word, does the second word end in IDE? Okay, now remember there are 3 exceptions. There are 3 polyatomics that do end in IDE. That's hydroxide, peroxide, and cyanide. Okay, so just remember that those are exceptions here. But in general, if it ends in IDE, yes, then it's binary. So you would find the charge of the nonmetal, on the periodic table. And crisscross. Okay, so here, very straightforward. Find the charge of the nonmetal, crisscross with the charge of the metal. What if the second word does not end in IDE? No. Then it's going to be non-binary. So for this one, you're going to find the formula for the polyatomic ion. Put it in parentheses and crisscross with the metal. Okay. So that covers all of our ionic formulas. Okay. Monovalent, multivalent, non-binary, and binary. So let's hop over to the other side of this equation and let's talk about what if the first element is not a metal. Then this substance is going to be covalent. Now, if it is covalent, we need to decide whether or not it is an acid of some sort or it is a binary covalent. So what would be the most important thing to ask ourselves when we're looking at the name of a compound in order to determine whether or not it's an acid or a binary compound? Very straightforward idea. Does it end with the word acid? All of our acids end with the word acid, whether it's a binary acid or an oxyacid. All the acids end with the word acid. Okay, so let's go with no. What if it does not? What if we're not talking about an acid? Then we have a binary covalent compound. So here we would use the prefixes to determine the subscripts, the little numbers. Okay. So then what about yes? Okay. What if it does end with the word acid? Well, then it's an acid. Okay, but there are two kinds of acids. So if you're looking at the name of an acid, what would be the first question you would ask yourself to determine whether it's going to be a binary acid or a non-binary oxyacid? The question you would want to ask here is, does it start with the prefix hydro? If the answer there is yes, then you're dealing with a binary acid. Okay, so when you have a binary acid, you're going to put H first, then the symbol for the other And then you are going to crisscross charges. Okay. So what if it doesn't start with hydro? This is where things get a little exciting. If it does not start with hydro, then it's non-binary or an oxy acid. So step 1, put H first. All acids start with H. Step 2, look at the ending. If it ends in ic acid, that is an 8 polyatomic. If it ends in us acid, that is an 8 polyatomic. So then you are going to find the polyatomic ion. Put it in parentheses. Crisscross charges with hydrogen. And there we have it. We now know how to write the name and the formula for any compound we are given.